this kind of a technique that surface wave measurement can be used in soft materials, and so it means that for any soft materials, right, you can just be imaginative with all of the different potential applications. If we look at kind of the food industry as a whole, there's about 1/3 of food is lost. So this is one potential area where reducing any of the losses in manufacturing could have a pretty big impact by leveraging this technology. The main thing that I would maybe just re-emphasize is that it's really fundamental. So this idea of like where it's applied is so wide open.
Hi, I'm Stephanie Whitehorse, Director of Intellectual Property at WARF.
And I'm Michael Carey, Licensing Manager at WARF.
Congratulations to Professor Karine Hennick and Professor Mila Ayrton for their nomination to the WARF 2022 Innovation Awards.
Their method for measuring the strength and durability of soft materials enables more accurate measurements in medicine, bioengineering, and food.
We look forward to continuing collaborations with this team. Congratulations on your nomination.
I'm Corinne Hennick. I'm an assistant professor in mechanical engineering at the University of Wisconsin-Madison.
I'm Mihir Tan. I'm an associate professor in the Department of Mechanical Engineering at UW-Madison. Polymer-based synthetic rubbers, gels, naturally occurring food. Most of the biological tissues in our bodies, except for maybe bones, are considered soft materials. In this technology, we're trying to get the quick and cost-effective way of measuring the mechanical properties, some important properties of those materials. Our technology provides a quick, compact way of getting those essential properties. Similar correlations were established already for traditional hard materials like ceramics and metals, but we are the first one to actually establish it for soft materials, and we believe it will open up a lot of exciting opportunities for further product development. And when we fail the material or fracture the material, part of that energy is actually released, especially around the damaged zones, and then propagates waves into the body of those soft materials and also on the surface. So we detect by non-contact vibration sensors those surface waves, and we analyze the frequency, amplitude, and intensity of those waves. Once instrumented, let's say, household items like knives, blades, shavers can actually collect that emitted waves from any product we cut, we shave, we process, and then maybe it can send it wirelessly to a mobile app.
It's a pretty fundamental technology, so there's a lot of different areas that we can apply this technology. What we are considering broadly is areas in food, medical applications, agriculture applications, and then other, including paper, pharmacological, that kind of thing. Food is where we've started in kind of developing the technology first, and in particular we're looking at cheese and cheese conversion. So in cheese conversion, they take really large blocks of cheese and they cut them into the slices we put on our sandwiches and the shreds we make nachos and other things with. And in that process, a certain amount of the cheese is actually lost. And right now, the current process for making adjustments to the conversion process, so the cutting parameters, things like that, is manual. There's a trained operator that slows down the line speed that makes changes as needed. If we add the sensors into the conversion process, it can be part of a feedback loop that actually changes those conversion parameters in real time. So this could allow them to cut either very different cheeses, so think a very stiff, brittle cheese like sharp cheddar to something very soft, more like mozzarella, or even just to make those more subtle changes over a single conversion process. For medical technology, we're looking primarily at surgical settings where a surgeon is already cutting the tissue. Thinking about a tumor case, that's where the unhealthy tissue is stiffer, so we'd be looking for the stiff versus the soft, healthy tissue. And we could have the flip in other cases. So if you have an osteoarthritic joint where there's a soft spot, a soft lesion, you could be looking for the stiffer, healthy tissue around it.
We believe, in fact, if we can go all the way to the consumer products, that would also open up a lot of opportunities for low, mid-income regions of the world. It would be quick diagnosis tool